Good morning. This is your stats sensei, Mr. Spensei, and we're going to go through the standard normal problem. So we're continuing on with the normal curve. So remember, every single time we're working with the normal, we need to be drawing a graph. So X is normally distributed, so they tell us it's normal. We need to know that. And it also has, in this case, a mean of 30. Having trouble with the pen, just a second. May have to switch out. There we go. Mean of 30 and a standard deviation of 4. So mean is 30, standard deviation is 4. So sorry about that. I'm obviously at school. So we need to go ahead and draw my normal curve. My mean is at 30. It says the probability that X is less than 40. So 40 is above it, but it says less than, so that means I'm shading this way. So it means I'm shading to negative infinity. So my norm, CDF, lower is negative infinity, upper is 40, mean is 30, and our standard deviation is 4. Now, I better end up with something greater than 50% because 50% would be halfway, and we're over halfway. So let's see what happens. So we go to second, press vars, normal CDF, lower is negative infinity, see negative 9 raised to the 99th. Upper was 40, that's the highest part of our shading. Our mean is 30, and our standard deviation is 4. But when we end up with that, we're way over 50%, and we should be over 50%. We end up with 0.9937. And one thing I almost forgot, so please do this. Make sure you label lower, upper, mean, standard deviation. The next one, it asks for the probability that X is greater than 21. So we're still working with the same problem, the same setup. So we're centered at 30. That's our mean. But we want to be at 21. Well, 21 is below this, but it says X is greater. So that means I have to shade up. We're going to shade all the way to positive infinity, which means this is going to be a norm CDF. The lower part of my shading is 20. The upper part is positive infinity. The mean is 30. The standard deviation is 4. And we need to get our labels in. Lower, upper, mean, standard deviation. So second vars, normal CDF. 21, 9 raised to the 99th. Mean of 30, standard deviation of 4. And we end up with 0.9877. And we should be greater than 50% because we're over halfway. That's not a very good box. The next one says, what's the probability that X is between 30 and 35? Well, once again, we draw a normal curve. Our mean happens to be 30. And so we wanted to start at 30, but we want to go up to 35. So this is what we're looking for. So again, normal CDF. Lower is 30. Upper is 35. Mean of 30. These happen to be the same this time. And a standard deviation of 4. Lower, upper, mean, standard deviation. Second vars, normal CDF. 30, 35, mean of 30, standard deviation of 4. This is going to be less than 50%, and sure enough, we get 0.3943. To be exactly 50%, we would have had to go from 30 all the way to infinity, but we didn't. So a radar is used to measure speeds of cars on a motorway. The speeds are normally distributed. That's important so that we can use the normal with a mean of 90 and a standard deviation of 10. So mean equals 90, standard deviation is 10. what is the probability that a car picked at random is traveling more than 100 miles an hour? Or 100 kilometers an hour, excuse me. So once again, the mean is 90. But we're at 100, so that's above it. We're going to go to positive infinity. So we have a norm CDF. The lower part of our shading is 100. The upper part is positive infinity. The mean is 90. And the standard deviation is 10. Lower, upper, mean, standard deviation. Clear. Second vars, normal, CDF, 100, upper, 9 to the 99th, that's our infinity. 90 is our mean, standard deviation of 10. And we end up with about 16% or 0.1586. All right, number 3. For a certain type of computer, the length of time between the charges of the battery is normally distributed with a mean of 50 and a standard deviation of 15. John owns one of these computers and wants to know the probability the length of time will be between 50 and 70 hours. All right. So we're at 50. That's our mean. And it turns out he's interested in 50 all the way to 70. So this is what we're looking for. They didn't ask for this, but if they had, I could have said the probability that 50 is less than X is less than 70, because they wanted it in between those two scores. So in this case, it's just a norm CDF. The lower bound, the lower part of the shading is 50. The upper part of the shading is 70. The mean is 50. And the standard deviation is 15. So lower, upper, mean, standard deviation. So what does that look like? Second vars, normal, CDF, lower 50, upper 70. Mean was also 50. And our standard deviation was 15. And I end up with about 41%, 0.4087. Number 4, the length of similar components produced by a company are approximately normal, with a mean of 5 and a standard deviation of 0.02. So mean is 5, standard deviation is 0.02. What's the probability that the length of the component is between 4.98 and 5.02? So the probability that 4.98 is less than X is less than 5.02. That's what they're asking for. So if I'm drawing my picture, now I didn't have to make that statement. It says the mean is 5. Well, it turns out 5 or 4.98 is below it, and 5.02 is above it. Now, technically, this is one standard deviation above or one standard deviation below and one standard deviation above. So that means by empirical rule, it should be 68%, but it's 68% is only an estimate. It's not as precise as what we're going to get, but it's going to be really, really close. So my low is 4.98. My upper is 5.02. My mean is 5, and my standard deviation is 0.02. Lower, upper, mean, standard deviation. So we should be getting something really close to 68%. So second VAR's normal CDF 4.98, 5.02, mean of 5, standard deviation 0.02. And we end up getting 0.6826, pretty close to 68%, which is what we said by empirical rule that it should be. Same problem. What's the probability the length is 4.96 to 5.04? Well, once again, this should be, by empirical rule, about 95%. It's going to be a little bit different. This is a little further off than the one below it. And the reason I said that is because this is basically 2 standard deviations below and 2 standard deviations above. And if we were writing the probability statement, just so you get used to seeing it, probability of 4.96 is less than X is less than 5.04. So in this case, we're centered on 5. And this is 4.96. And this is 5.04. And we're shading in between. So this is going to also be a norm CDF. My lower is 4.96. My upper is 5.04. My mean is 5. And my standard deviation is 0.02. Lower, upper, mean, standard deviation. So once again, we should be fairly close to 95%. This is going to be a little bit different, but it's close. So 4.96, upper 5.04, mean of 5, standard deviation 0.02, and we end up getting 0.9544. So pretty close. 0.9544. It's not exactly 95%, but it's pretty close. All right. The length of life of an instrument produced by a machine has a normal distribution with a mean of 12 and a standard deviation of 2. So mean equals 12, standard deviation is 2. Find the probability is less than 7. So we want the probability that X is less than 7. Well, the mean was 12. 7 is below it, and they want us to go to negative infinity. So this is a norm CDF. My lowest is negative infinity. My upper is 7. My mean is 12, and my standard deviation is 2. Lower, upper, mean, standard deviation. Second VARs, normal CDF. -9 raised to the 99th. Upper is 7. Mean is 12. Standard deviation is 2. And we end up getting 0.0062. Not very likely. Then it says between 7 and 12 months. Probability that 7 is less than X is less than 12. Well, 12 happens to be the mean, and that's actually where they want us to start. They want us to start at 12. That's my line here. And then they want me to go to 7. So this is what I'm looking for. So it's a norm CDF. Lower bound is 7. Upper bound is 12. The mean is also 12. And my standard deviation is 2. Lower, upper, mean, standard deviation. Second VARs, normal CDF. 7, 12. And we get almost 50%. 0.4937. And if I added those two together, I'd be really at 50% for all intents and purposes. All right. We're looking at number 6. A large group of students took a test in physics and the final grades have a mean of 70 and a standard deviation of 10. If we can approximate these grades by normal, okay, they're saying we can use a normal. What percent of the students scored higher than an 80? So we want the probability that X is greater than 80. So in this case, our mean is 70, but we want 80 and above. This is going to positive infinity. So second vars, normal, CDF. 80 is my lower bound. Upper is infinity, so 9 to the 99th. Mean is 70, standard deviation of 10. So that's almost 16%, so 0.1586. To pass a test, they had to make greater than or equal to a 60. So we want to know the probability that they made greater than a 60. So my mean is 70. Well, 60 is below it, but it said greater than, so I'm shading up, and I'm shading up to positive infinity. So this makes this a norm CDF. 60 is the low, positive infinity is the high, 70 is the mean, 10 is my standard deviation. Lower, upper, mean, standard deviation. Second vars, normal, CDF. I just need to change my lower bound, to 60. This was infinity. There's my mean. There's my standard deviation. And I end up getting 84% or 0.8413. And we want to know the probability that they'd fail. Should be less than 60. Well, I should be able to subtract that, and I'm going to be 16%, 15 point something or other. So let's see what happens. So our mean is still 70. The upper bound of our shading is 60, but anything lower than a 60 fails. So we're going to shade to negative infinity. All right. So norm CDF. Lower bound negative infinity, upper bound 60, mean of 70, standard deviation of 10. So lower, upper, mean, standard deviation. Second vars, normal, CDF, negative 9 raised to the 99th, 60, 70, 10. So there it is, almost 16%. So 0.1586. And like I said, we could have gone 1 minus that, and we would have gotten this exact number. All right. The time taken to assemble a car, this is number 7, in a certain plant is random variable having a normal distribution of 20 hours and a standard deviation of 2. All right, this should say with a mean of 20. So our mean is 20 and our standard deviation is 2. What's the probability that it's less than 19.5? Oh, no, we have a decimal. No big deal. It's the same as what we've been doing. So this is 20. This is 19.5. Less than, so we're going to negative infinity. So this is a norm CDF. Lower is negative infinity. Upper is 19.5. Mean of 20. Standard deviation of 2. Second vars, normal CDF. Lower, we have the negative infinity. Upper was 19.5. Our mean was, 20. And our standard deviation was 2. We'll just check that out to make sure that we did that right. We have it. Press enter. And we end up with 0.4012. 0.4012. We make sure we label lower, upper, mean, standard deviation. Between 20 and 22 hours. So 20 to 22. So this is a norm, CDF. The lower is 20, the upper is 22. The mean also happens to be 20, and our standard deviation is 2. Lower, upper, mean, standard deviation. Second vars, normal CDF. And we end up getting 0.3413. All right, number 8. The annual salaries of employees in a large company is approximately normal distributed. So they're telling us we can use a normal with a mean of 50,000. Mean is 50,000. And a standard deviation of 20,000. What percent of people earn less than 40,000? Well, here's 50. 40 is below it. And we go to negative infinity. So norm CDF, negative infinity. Upper is 40,000. Mean of 50,000. And then 20,000 is our standard deviation. So second vars, norm, CDF, lower bound, negative 9 to the 99th. Upper bound was 40,000. Mean was 50,000. Standard deviation was 20,000. And it turns out about 30% make less than 40,000, or almost 31%, 0.3085. Lower, upper, mean, standard deviation. What percent earn between 45 and 65? So our mean is 50,000. This is 45,000 is below it. 65,000 is above it. We're looking for this. So norm CDF. And 45,000. 65,000. Mean of 50,000. Standard deviation of 20,000. Lower, upper, mean, standard deviation. Second vars, normal CDF. Lower bound, 45,000. Upper bound, 65,000. We already have the mean and standard deviation in. And we find out that it's about 37.3720. All right, the last one. What percent earn more than 70,000? All right. So once again, here's our normal. Centered at 50,000. But we want to be 70,000 or more. That's basically one standard deviation above. So we're going to go norm, CDF. Our lower bound is 70,000. Our upper bound is infinity. Oops. Well, that does not look like an infinity, but it's supposed to be an infinity sign. And here, I'll write it below it. There's our infinity sign, positive infinity, mean of 50,000, standard deviation of 20,000. Lower, upper, mean, standard deviation. Those second vars, normal, CDF, lower bound, 70, 1, 2, 3, 70,000. Upper bound, 9 to the 99th, 50,000, 20,000. And we about 16%, 0.1586. So 0.1586, about 16% make more than 70,000. Appreciate you watching. Hope to see you on the next one.